welcome back after room change, and there wouldn't be a technology conference without technology problems. This is Renee. Renee Noble is the director of the Girls Programming Network and a software engineer at edutech company Grok Learning. Renee's passion is education and community development, and when she's writing code to help build the Grok Learning platform, organising the next Girls Programming Network workshop, or even teaching a swing dancing class. Renee is there to spread her passion, knowledge and joy to others and encourage them to pass it on, which is awesome. And she is talking about Scissors, Paper, Rock, your classroom with differentiated projects. Thank you very much, Renee.
Thank you, Amanda. As Amanda has said, I'm Renee. I am the director of the Girls Programming Network. I am a software engineer and content developer at Grok Learning, and I'm supported by Data61, who helps me with my GPN various adventures. And I'm here to tell you about how to scissors, paper, rock your classroom with differentiated projects. I'm going to get to exactly what scissors, paper, rocking is, but it's basically a methodology we've come about through the Girls Programming Network, or GPN, as I'm going to call it throughout this talk. And I'm going to tell you a little bit about GPN first to give you some context. So, GPN is a program that provides free coding workshops for girls aged 10 to 18 around the country. A typical Sydney workshop would have 170 girls. We luckily have a large amount of women there to help tutor them on the day. We have about 60 women there to help out. And we have a 6-hour day, probably about 3.5 to 4 hours of coding in that. And we're creating Python projects in that day. We have girls from all levels of programming experience, from complete beginners who've never touched code before in their life to kids who've been coming to GPN for 5 years. And basically our idea of the day is to give them an authentic programming experience where they create this project. And essentially, we all want to get more girls into code. So our methodology of getting girls in there is no barriers to entry. We don't want any scary prerequisites. We don't want any scary leveling things. We don't want something that's going to stop them from clicking sign me up to GPN before we get there. So we're all about eliminating those barriers. So we're just about creating a fun, exciting sounding thing that the girls are happy to sign up to. And on the day, they get there and they create a really awesome programming project. So why do we need to differentiate our projects? We have 170 girls. They've signed up with our no barrier approach to entry. And so we have no idea how much programming they know. They don't know how much programming they know either. So we get there on the day and we kind of have to work out how much they kind of know, and then we have to have a project that is flexible enough to let us go on the fly with whatever girls we get turning up on the day, and everyone needs to have a fun and awesome time creating a project. The thing is, we advertise one project. So for our Scissors, Paper, Rock project day, we'll say, come and make Scissors, Paper, Rock, a fun text-based game. Every girl needs to go home at the end of the day and say they made a Scissors, Paper, Rock game. But at the same time, we need everyone to go home and say, I also learned something really cool, and it was hard, but it was really fun. So we have this broad range of abilities and a broad range of ages as well, and different learning paces. And they all need a challenge, but they all need to make something that does the same thing. And we can't just say, well, we'll make a really bad version of Scissors, Paper, Rock and beginners, and we'll have a fantastical, gooey excitement extravaganza over here in our advanced classroom. It all needs to look like everyone did an awesome project, and everyone just needs to feel challenged and like they've extended themselves in their programming knowledge. So we have done a bunch of different projects at GPN, and as we've grown and we've got more girls and we've spread around the country and we've broadened our program to a whole range of girls, whether they be in Cairns or Canberra, there's a whole range of abilities of both the girls and as well as the tutoring staff, whether they're university students, they're school teachers, or they're hobbyist mums who want to help out and get their kids into coding, or they're professional software engineers. We have a whole range of people helping out to teach this. So we've had to grow our methodology to be able to support allowing these people to help get girls excited about coding. So we've had a bunch of projects over the years that have helped us create this methodology that I'm going to tell you about today. So I'm just going to tell you about some of the things that we noticed along the way that helped us pick out what was important about a project and what you might want to avoid. So I'm going to take you through the good, the bad, and the ugly bits of different projects. And I love all of our projects, but there's always a part you're like, well, I wish this was a little bit easier, or that was great, and I'd like to replicate that again. So I'm going to start with some of the bad. the bad ideas. We used to, when we only had, 50 girls, we had 2 classrooms and we didn't have any workbooks. I'm going to tell you about how we make workbooks today. But we used to go straight off slides. Everything was on slides and the kids would have to kind of code along and go as as the lecturer went through it in the classroom. The problem is some kids get ahead, they get bored, they start distracting the rest of the classroom. Some kids get left behind, they're headed over 5 slides later and they're still trying to do print hello world and they don't know where to go next. So at some point we moved to workbooks and it turned out it was a great idea because everyone could move at their own pace. But we still have lectures that we want to be able to keep all the kids in sync for. Also, we've done a bunch of web dev projects, so this is our cookie clicker project, but the problem there is we have to give them a bunch of stuff first. So we've gone, here's all the HTML, here's all the CSS, and we just want you to do the JavaScript stuff for today. But then we get stuck with the girls don't really exactly know how their thing is working, so they couldn't go home and make a new project by themselves. They know how to add something to something, but they don't know how to start it from scratch. So it's not a complete, authentic programming experience. And then we've had projects that were tech-led rather than project-led. So we're like, we really want to try something with these NIC-to-ED1 Arduinos, or we really want to teach the kids networking. But we've started with the idea first of what we want to teach, and we haven't had the narrative or the thing we're going to build first. So starting from there, it made it hard to make it an interesting experience for the kids without making it trivial or just kind of something we've fabricated just so we could teach you this one thing we wanted to teach. Now onto the ugly things. I love Pygame, but it's a bit tricky sometimes. Firstly, installing it, we heard about that in the last talk. It's a nightmare. Secondly, you end up with a bunch of boilerplate code sometimes, and you're just like, just trust me, kids, you want this here. It's valuable. Yeah, you'll understand it later, maybe, one day. It's fine. So we've created our Flappy Bird game in Pygame, which the kids love to make, but it does require a bit of hand-holding because there is a lot of steps to getting a working game in 3.5 hours. So we do have to give them a little more structure than we might want if, that we see in our other projects. Another thing about Pygame is you really need to get that game loop going early. We have a fun story about a workshop where we were like, no, we really like teaching our projects in this order: variables, if statements, then loops. Problem is you get this game loop happening last. So we got to the if statement section and we're going to create an event handler, and then we're going to do something on that event handler happening. The problem is we had an event handler that happened just once and it was looking for any event. So we had a whole classroom of kids being like, why doesn't my project work? I can't get it to press the space button and do the jumping. I'm really sad. And then, half an hour later, we figured out it was just other kids bumping the table and the mouse movements setting off that single event handler before we got to the loop section of the day. So, you have these caveats that if you want to, use Pygame, you really just have to get that loop happening early. Otherwise, it's not going to be a fun time for anybody. We've also got our Markov chains project. We like to create green eggs and ham the second, where kids generate their own, fun stories from existing texts. But the problem with this workbook is the kids really love what comes out at the end, but we do a 10-minute lecture, you write 1 line of code. You do a 5-minute lecture, you write 1 line of code. The problem with Markov chains is it's too tightly wound. It's too simple. You can write a Markov chain, an awesome program, in like 10 lines of code, but you don't want to just write 10 lines of code in your 4-hour coding day. So those are some of the the things we've learnt along the way. You want more code, you want less boilerplate, and you want to make the kids understand everything they're coding on the way through. So that gets to our good parts of our journey, which is our scissors, paper, rock, our canonical example of the GPN workbook methodology, where I'll take you through an example of how we came to that and how you can apply that to hopefully any project you can think of. And we've got other things that just involve writing a lot of Python code using basic ideas, variables, if statements, and loops, and a little fun bit extra on the side. These include our sassy chatbot, where we've just got the kids are trying to guess a password to a secret diary, and it's just going to be really sassy to you, make you doing annoying maths questions and never let you into the secret diary. And we've got our cryptography project, where we create a Caesar cipher, which is combining these simple Python processes with a little bit of algorithms to make a really fun thing that the kids love to send secret messages to each other with. So, how do we make a project that fits all levels? Well, what we do at the start of the day is we do what we call our streaming quiz. It's a fun quiz. The kids come in and we need to work out what kind of level they're at the start of the day. Because we can't, it's really difficult to say we're going to have one project, singular, and then everyone's going to start at the same point and we're going to just add all the concepts on together. So what we actually do is we do 3 projects that are the same idea. So we're going to have 3 versions of scissors, paper, rock by the end of this. So we work out if the kids have done no programming before or they really need a refresher on the complete basics, we work out that they go into beginners. If they are kind of comfortable with variables and if statements, up into intermediate you go. And if you're pretty confident in variables, if statements, and for loops or while loops, up into advanced you go. We're going to extend you into some other harder concepts. So we've got our basic beginner projects here, beginner, intermediate, and advanced. These are our base level workbooks. These are where we're going to cover our core concepts. So in beginners, we're going to cover our if statements, variables, loops, probably input or some sort of event handling thing. Intermediate will cover all of those plus one of functions, files, or dictionaries, so a harder level concept. And advanced, all of those previous ones plus OO, or OOP. I really like that name now. We next take those workbooks because we've still got that gap. We've got kids who will end up, it's like, oh, I'm not quite intermediate, but I'm not quite advanced. I'm not quite high enough, so I'm kind of going to be bored at the end of the day. We need to add a little bit more flexibility to this arrangement. So each of these bars is representing our effort load or our kind of workload for the day. So we're going to add in these bonus activities. So we kind of slice them in as we go along. And these are activities that are placed inside the workbook as kind of extra things they can do. They're completely skippable. They're just things that add functionality to the project. So something that will slow the kids down, moving the faster kids sideways rather than exacerbating the problem by giving them extra knowledge that's going to get them moving ahead even faster. And these are things that don't normally require any lectures. So it's this little box, we're going to give you a concept and you're going to have to figure out how to put that into your project. And I'm going to go through a few examples of these later. The great thing about these is when we want to keep our class together for lectures, we can say, how about you just try the bonus at the end of part 3? And then while you do that, everyone else is going to catch up and we'll all move on to part 4 together and we'll all be able to cover the lecture material at the same time. So it's good for keeping everyone cohesive. Finally, we add on our last bit, which is extensions. We just make the project go forever. If you've got a kid that's covered all the core concepts together with your class, but they're just flying through, just hand them a bunch of extensions. The great thing about extensions is you can take the project that they now completely understand and then they can rearrange it, they can add in more concepts, and you can do a lot of creative things with this. So we can edit our existing project or we can add to it. We could do multiple extensions in any order, or you can create a bunch of extensions that keep building on top of each other, kind of just keeping along with that project idea of keeping moving through. And it's a great way to cover extra concepts you might want to cover, but not want to cover with the whole class. It's kind of separating it from your core project makes all the kids feel like they've achieved the whole project, and then some kids get to do it a little bit extra. So we need to make an ideal idea first before we get started. So this means we want to find a project that is realistic for beginners, and then we're going to extend on that. So we're going to start with fun project ideas. So we need it to be fun. It needs to be something that's going to give them a sense of completion, something that they're going to understand and be able to own, something that's going to be interactive, and something that's an authentic programming experience, something that's going to be able to relate to something that's in the real world for them. Cool. So now we need to, this is a good owl, right? We'd all love to be able to draw this owl one day, yes. But it's not really an achievable drawing project for a beginner. And do they even care about drawing this owl? Possibly not. They want to draw something fun, something cute. I don't think they care about this photorealistic owl that, it would be cool to draw, but, they might actually want to draw something else more. So what I'm saying is when we create a project, we don't have to create a perfectly shippable project that does all the bells and whistles and accounts for all kinds of users and all kinds of misinterpretations. What we want to do is something fun that the kids are going to understand. And what we do need to do is we need to have all the steps from getting started to the finished project that we want the kids to take home at the end of the day. this here, clearly missing a few steps, but it's also missing the idea that beginners don't have, even if we had infinite time, they might not be able to get to this owl by the end of our infinite time project, because it's that practice using those skills in different scenarios that gives us our ability to texture this owl. We can't just teach one programming concept and then assume it's set solid in their brain and just keep building on top of that. We need to give them time to rest and then put all those ideas together over a much longer, probably several projects. So what we want is this owl. It's much more achievable. I think kids will actually like this owl a lot better too. It's cute, something they can relate to. And that one there is definitely an owl. And we don't even need to get to the end. So what we want with our projects is something that takes you one step at a time, and every step at the time you're getting a little bit closer to the owl you want to draw or the project you want to make. So even if you only get to that fourth owl there, you can say, I definitely made an owl today, and I can't, don't have a problem with that. I know there were bonus owls you could draw, but this one was a good owl. So what we want with our projects is a clear progression, and at every step of the way we could say, there's a clear part we're drawing here. We're drawing the eyes, we're drawing the circles around the eyes, give it a body, a beak and a tail, and that's pretty much an owl already. So creating a project like this for your programming class is what we're aiming for. And it's also great because we want a project like this where we can divide up our project into discrete concepts. So here it's draw a body, but it might be implement an if statement in your program, and being able to punctuate our project with those different lectures is what we're aiming for. So this is our beginner's scissors paper rock code, and what we've got here is just four key concepts, and what we want to play with all our code games is concept golf. So we often play code golf when we're creating code, and this clearly isn't code golf because it has 9 if statements in it, which you might be like, that's not very pretty, but what it is one concept, which is, just learning those concepts is the hard part of teaching programming. So what we have here is a while loop that just loops forever. You have randomly choosing a computer move, you have setting a human move, and you have lots of if statements to decide the winner. Just 4 concepts that make a game. And what this game actually looks like is, it's going to look like this. And this is what all our streams are going to make at the end of the game. We get to input our move, and then it's just going to keep playing more games. So basically, it just asks you for your move, and it chooses one to verse you randomly, and that's what we get. So that's our beginner's project, but our advanced and intermediate projects are actually going to have an interface that looks exactly like that. It's just going to be harder to get to it with more steps. Cool. Okay, cool. That's mostly on the screen. That's fine. So we've got this code idea, and we want to know if it is a good idea. And what we've developed to kind of get out of that intuition, so people show me code and they go, Renee, is this good? Is this a good thing we could do at GPN? And I go, kind of-ish, maybe. Here's the things I kind of think. And this is what we did for our coding competition recently when we're trying to design new workbooks. So this is our table of how hard it is to learn each concept. So these are how many points you would want to kind of put aside if you were trying to teach a concept. So, we've got print statements, they're really cheap, but we've got functions, they're pretty, expensive to use. So, and we've also got 3 different categories of things in here. So we've got our Python concepts, so those are just, your if statements, your loops, print, functions, whatever you can think of. Then we've got 2 other categories, our tech and theme concepts. So just adding on things like, we want to use Pygame. That's just a huge overhead. If we want to use that, there's a lot of bits and pieces we need to understand. Or we want to just add algorithmic thinking. We want to do cryptography or something. It means the kids do have to spend a bunch of time in the day working out how that concept relates to the code. So we have to factor in these different bits and pieces. Then we have our code construction concepts as well. So things like nesting or a list with tuples inside of it means, that's an extra concept, trying to get those in the right order, or just having a lot of stuff to type are all factors in, you need to factor in to make sure your project isn't too hard on the day. So, yeah, just looking up close, we can see there's a whole range of different, expenses you can pay. And what we go for on the day at GPN is 45 to 50 points for our base level project. So this is what we get when we tally up our beginner's scissors, paper, rock game. So we've got all our different concepts we had there, and we have additional use of structures. We have 9 if statements, so we have to pay a penalty for those ifs and elifs. And we have nested code as well. We have our if statement inside a while loop, and just getting the kids to put them in the right order, just getting them to indent that code just costs you a lot of points. So, yes, so once we have that, we get to break it down into steps because we want to properly draw that out. What we do at GPN is we like to teach things, hopefully in a pedagogically appropriate order. So we start with the print statement. We often add things that aren't in the final code just to step them through it. So we first start by hard coding a computer move, and then that's a nice, simple use of variables. Then we move on to input, asking the player for a move. Do all the if statements. And the great thing about the if statements is if you need help on the first one and you need a bit of hand-holding, that's okay, because you're going to have 8 more ones you're going to do by yourself to cement that understanding. Finally, oh no, not finally, we get to randomize the computer move next, which is the part the kids love. They just love that the computer can choose random things. And then finally, we add the while loop. Cool. So now it's time to differentiate the projects. So we want to get to this ultimately at the end. We've got our bonuses in the middle, we've got our extensions at the end, and we've got our beginners, intermediate, and advanced. So first, I'm going to take you through adding in some bonuses. Things that we like to do at GPN to add some bonuses are things that make it look, fun. So the first one I'm going to say is our ASCII art. So instead of just saying computer played paper, computer played I am a sheet of paper. Much cuter. That's a fun thing to add in. It doesn't change the functionality of the game at all. So it's just a nice sidestep to distract the kids for a while and see what they can do with text. Another one I like to use is sleep, time.sleep. Kids are always like, I wish our computer thing seemed more like a person playing. I'm like, great, we're going to use time.sleep. You tell them this one line. Time.sleep is a thing that exists, and now they can go and add it through their game wherever they like. They can spend 5 minutes putting that in throughout their game to slow it down and make it seem more fun. Next, we have our extensions, so things that go on to the end of the game. This is a great example. Here is our scissors, paper, rock, lizard, Spock. It's a way they can extend their game with more, this fun, meme version of the game that they might have heard of. Or we can add things like a high score table using, files or something like that. And then we finally want to get to leveling up our project. So we want to take our beginners, intermediate, and advanced projects into the day. So we need to take our beginners one, and we're going to take this to intermediate and advanced with some concept switching. So what this means is we've got this is our beginners project, and what we're going to do to take it to intermediate level is we're going to see what we can do to make it a bit more elegant and add some more concepts. So what we've done is we've removed a million if statements, and we replaced it with this nice dictionary instead. So they get to investigate dictionaries, and instead of just having that while loop that just went forever, we're going to properly investigate for loops, iterating through those for a fixed number of games. Then, to step this up to advanced, we get into objects with methods and attributes. We're basically going to take our intermediate program and wrap that up nice and tightly using classes for players and for the game as well. Finally, we get to this table. So what we have here is now we have a column for beginners, intermediate, and advanced, and we assign them different points and how hard the concept is at that level. And you might say that's a bit strange. You could just have instead of having a 45-point project in beginners, and you might want to have a 90-point project in advanced. But what we'll do with this table here, firstly, we have some things that appear that didn't appear before. We don't want to teach OO to beginners. It's a little bit scary. But also some things become free. So print, that's now free in advance. You don't have to think about it. They'll just chuck it in there. You don't have to tell them otherwise. Some things become easier. So if statements, they still take a bit of time to type out, but you don't have to teach them from scratch. So instead of being a 4-point thing, they're now a 1-point thing. But what is interesting is some things never get easier. For instance, making a creative choice, where they get to make something pretty, design it themselves. No, it's always 5 points. They always get as distracted, whether it's their first day programming or they've been doing it for 5 years or they're a software engineer. It's still 5 points. It still takes a lot of time to decide. So this is how we at GPN create projects that mean we can teach girls all around the country how to code in these one-day workshops with tutors of all different levels of capability, students of all different levels of capability, experience and ages. And so we hope you give one of our calculators a go, play concept golf rather than code golf to simplify your projects, and add some bonuses and extensions and different levels to see how you can differentiate your classroom. And let us know how you go, because we're still working on this methodology, and yeah, we want to see how it works for you. Maybe you need a different amount of points in your classroom, whether you're doing it for 3 hours or 3 weeks or 3 months. We'd love to see how it fits in with you. So yeah, let me know how it goes. You can email me if you are a woman who codes or you know one and you want to tutor at Girls Programming Network. We would love to have you. So go to girlsprogrammingnetwork.com and click the Become a Tutor button, and then I will send you emails and it will be fun and you will get to scissors, paper, rock with me.
Excellent. We have time for maybe one question. While someone is putting up their hand, I'm going to read off the slide that it's girlsprogramming.network.
Ah, yes.
One question. Excellent.
This is an easy yes/no question. Is the calculator, is there an actual web calculator? Okay.
Not yet.
That's a hashtag
Yet.
concept.
But we will take pull requests.
Yeah, we will. Yeah, we
Yeah,
will.
that's the yet answer.
Yet.
Thank you for volunteering. That was super short. Is there anything else? Yep.
Do you run them in all states or only?
We have them currently in Sydney, Canberra, Perth, Cairns and Mackay, and others pending. Yes, there will be, yes.
And some of them are run by software professionals, and
Yes,
some of them are run
school
by
teachers.
school teachers.
Yeah, basically anyone who wants to run one, you can have one later. We're working on making it highly scalable.
Yeah. Is it hard to find a venue?
Well, we try and, we work with the University of Sydney, so it's easy for us, and lots of schools are willing to open their doors and things like that, yeah.
But if that was someone offering a venue somewhere, please get in
Yes.
contact. Is
Yes.
that what you're, yes?
Yes, yeah, you seem to have a venue, good. We will have that.
All right, thank you so much, Renee. I'm going to mug you. So exciting.
Thank you, Nikki.